Chromebook should be put up. You don't need your Chromebook. You should be with me. Phones put up, AirPods out. So you're giving me your full attention. It's called active listening. It's called active listening. It's when you're not passively listening. Passively listening would be like if you were still on your Chromebook or on your phone as I was trying to give instructions. Do you mind putting that away? Thank you so much. Active listening is like leaning into it, okay? Learn how to be an active listener when the time is needed, and then you'll find that you don't have to listen as hard because you're actively listening. Also remember, I've been trying to teach you self-regulation strategies. Literally putting the phone away from you has been proven to increase like comprehension and overall academic achievement in the long-term study that they did, because it's mental energy. All right, we took our test on Friday over transformations. We're still in Unit 3, but we're in what's called like Part B, because it's not transformations necessarily, but we're still in Unit 3 when we're talking about overall shapes. If you look at the name of this sheet, it says congruent figures. We are going to learn what it means for two shapes to be deemed congruent to each other. What does congruent mean? We've already talked about congruent before. Equal. If something is congruent, we learned that it meant it had the same measure, right? Congruent means a copy of. If we're talking about the shape overall, we mean every corresponding part is congruent. So like, the bottom left corners are equal, the bottom right corners are equal, the top left corner is equal, the top right corner is equal, the sides in between are equal. So basically it is like a cookie cutter. I picked it up and I did a cookie cutter and I have two of them. Everything's the same. This is page 40. Let's take a few notes and then we'll dive into the practice. Not a lot of room up there to write 40. All right, we're looking at congruent figures. The bulk of the new info will be right here in this box, and then we start practicing, and then when we get to the back, we're going to start coming into what's called proofs, and we'll talk about that when we get there. Polygon, if you recall the word polygon, it just means a closed shape with straight edges, like no curved edges, no open shape, like it's all closed. Congruent polygons have, this is a tongue twister, congruent corresponding parts. That's exactly what I just described to you. Now these two shapes are not turned in the same direction. Would you agree? One's facing a different direction. Trying to find, none of them are. That's great. We're just going to go with, when life doesn't line up. They're matching sides and angles that correspond are congruent. When you name congruent polygons, you must list them in the same order. This is really important. When you name the polygon, you've got to go in the same order as the congruent parts. Now, these two shapes, although they don't face the same way, it's pretty obvious like what sides correspond with each other, because they have distinct look about them. If I'm going to name this shape A, B, C, D, A, B, C, D. If this is the shape or the way I'm going to name that one, right? Then I have just set the tone for how I have to name the second one. Notice I drew the arrows to help you see my train of thought. I went A, B, C, D. I cannot come over here and name this MQPN. I can't name it that. I've got to name it in the same manner. So what does it look like corresponds with A? It looks like M corresponds. And I went from A to B, so what direction do I need to go here? M to N. And then N to P, and then P to Q. So I have to name this one M, N, P, Q. Order matters. Here's why it matters. If I didn't give you the picture, okay, imagine the picture's not there at all. Let's see if I can do this without taking up a lot of time. Imagine the picture's not here at all. And I just said, hey, I've got two shapes that are congruent to each other. ABCD is congruent to MNPQ. If that's all I told you, you don't even know, you know it's a four-sided figure because you can see you have four letters. But you don't know what it looks like, right? Could be a square, could be a rectangle, could be a parallelogram, could be a rhombus, could be a trapezoid, could be some weird shape that has no name. If I tell you the congruence statement, I've just told you all the parts that are equal. So watch how I can read all the equal parts from the congruence statement without even needing the picture. This means angle A must be congruent to angle M. This means angle B must be congruent to angle N. This means angle C must be congruent to angle P. Angle D must be congruent to angle Q. Naming the angles is the easiest part because you just name them by two letters and they're in the exact order of how they're written. What's left to talk about is the sides, but it's the same concept. Watch, I'll use a highlighter. Side AB must be congruent to side MN. AB must be congruent to MN. BC must be congruent to NP. BC is congruent to NP. CD is congruent to PQ. Now you might be thinking, where do we get the last one? What combo of letters have I not done yet? I've not done the first and the last letters. So you do have to read this. They're separated, but you could say AD or DA, either one, must be congruent to the first and the last letters of the other shape. Now, however you name the first one is how you need to name the second one. So if you call it AD, you would need to say MQ. If you call it DA, you need to say QM. Now, I got all of that info by just looking at this. I didn't need the picture, right? So this is to tell you, to show you that as we do our practice problems, this is mainly in the directions. You need to read the directions because if they give you a congruence statement, they have just told you every part that's equal. It's just a matter of reading it in the same order, okay? That's huge. That's a lot of info. And you're going to see how to apply it in a little bit. So this is called the congruence statement. This tells me that the two shapes are copies of each other, cookie cutter copies. And then by looking at this, or by looking at the shapes, I can write out all the parts that must be equal. All right, look at number 1 right here. It says complete the congruence statement. We have these two shapes here. They've got the congruence statement right here. They're asking, so what is RS congruent to? What is angle D congruent to? I want you to fill that in. Try it before we go over the answer. So side RS is congruent to side what? FG. If you're looking at the picture, it's probably difficult to really figure out what it's congruent to. But if you look at the congruence statement, it's just a matter of reading it. RS is the last 2 letters, so FG is the last 2 letters. Angle D is congruent to angle what? P. Oops, angle P. What's the angle part out? All right, you do 2 through 4. Please participate with me. Okay, so we're looking at, we have 2 shapes. This one's not too difficult to figure out what lines up with what by looking at the picture, but I would encourage you to focus on the congruence statement if it's there, right? There's no need to look at the picture. They're telling you the order of the letters. So what side does HL congruent to? MQ, thank you. And then what angle is K congruent to? Angle P. It is just a matter of looking at the congruence statement. All right, down here we do have 2 triangles. They are not turned the same way. Triangles might be a little easier to decide what's equal to what just by looking at it because there's only 3 things to work with instead of 4. WV, CB, angle V, angle V. Something that we've not written down, if you would, I want you to take note of the computer acting up. I want you to take note of this notation means I'm talking about what part of the picture? A side, a segment, right? That means sides, and of course this means angles. I know it feels silly to write that, especially because the angle symbol, we've been practicing with it. Please write it. I have seen people get these wrong because they mix the 2 up, okay? Please know when you're dealing with sides, know when you're dealing with angles. How do you know when you're dealing with which? First of all, an angle is never named by 2 letters. It's always 1 letter or 3 letters. Second of all, a side is never named by 1 or 3 letters. A side is always 2 letters. So the number of letters is a sign. The second way to know is the notation, okay? Number 4, side GF is congruent to side YX. Angle Z is congruent to angle H. Now, some people might have taken off with the rest of the sheet, which is perfectly fine. The difference in 5 through 8 from what we just did in 1 through 4 is they actually have measurements on them. So now it's actually saying, hey, tell me the length of the missing side, or tell me the measurement of the missing angle. The concept is the same. we have a congruent statement, we have the two pictures, we can figure out what x and y is. X is here. Watch how I do this, because this is where it starts to get a little trickier. There's more layers of thought. X is on the side DF, right? Look at the congruent statement. DF is the first and last letter. So DF must be congruent to JL. If I come to the picture, JL measures 8, so X must be 8. That's the thought process you're going to go through. Now, do you have to get a highlighter and highlight the whole thing? No, you don't. But I wanted you to see where my mind is going. I see I need X. X is DF. I'm going to go to the congruent statement and see what does DF correspond to in the other shape. And then I find that side, and I get that it's 8. So this is 8 inches. All right. Next says to find y. Repeat the process. dy. Now this would be a process of elimination. You should know what y is, because now you know that this is 8. You know this is 10, and then the other side was 6. But let's pretend like you didn't pick up on that. So DE must be congruent to JK. JK measures 6. Again, I know you might think this is a little too easy. It's laying the groundwork for where we're going, okay? You got to get through the easy stuff and be able to understand it to get to the more challenging stuff. All right, I would like you to try 6 through 8 right now. So again, you read the congruent statement. X lines up on BC. So you come over here, BC corresponds to QR. So X must be 13 centimeters. Y is side AC, which corresponds to PR, which means it's 14 centimeters. The next two figures, you do have your congruent statement. It's asking for X and Y. These are angles this time. You should have found X is angle P. Angle P is congruent to angle C. So it's 125 degrees. Y is in angle Q. It's congruent to angle D, so it's 55 degrees. For 8, you should have found it to be 120 and 100 degrees. Does anyone have any questions on those? You want a whole test on this, right? All right, if we go to the back, we have 2 more. If you've not done them, please do them. On the values of the variables, they give you the congruent statement. What did you get for X here? 5. What about Y? 13. What about X here? And Y? 20, 21? 21? Let's work those just in case. So when you started these are slightly different because they're polynomials. They're not straight up X and Y, right? So it says find the value of the variables. Here's our congruent statement. Here's the first variable, 5x. 5x is along the edge KL. KL corresponds to what in the other shape? EF. With me? So what is the length of EF? Or where is EF? EF measures what? 25. So I don't know right away what X is, but I do know that KL has to measure 25. So watch this. I can say to myself, this has to measure 25, and there's your equation. 5X has to equal 25. So X must be 5, right? You do the same process with Y. Y is in this expression 2Y, it's KJ. KJ is the first two letters. So ED, 26. So this measures 26. And there's my equation. 2Y has to equal 26. So Y must be 13. Same concept with number 10. Might be a little easier because it's just angles. You just have one letter to read. You don't have two. X is right here, angle Q. Q is the last letter, so it must be congruent to D. So 15X has to equal 60 degrees. Divide by 15, you get 4. Then we've got Y right here. Can't do two arcs, so I'll just make it look a little different. Y is in angle N. N is the second letter, so it's congruent to angle B. So 5Y must equal 105. And that's where you divide to get 21. So the front was where they're just straight up equal. The back is where you did have to set up a little equation to solve, but it was the same concept, right? You find the side that it corresponds to, and that's what the value must be. All right, come down here towards the bottom. We are getting into proofs. Proofs is probably the worst part of geometry, okay? What makes proofs so challenging is it's like a different way of doing math. It's an argument. It's putting your logical thought on paper, and a lot of people are uncomfortable with doing that. Proofs are the equivalent of being a lawyer, going in a courtroom, and trying to prove your case. Whether you're a defense attorney or you're trying to prove that your client is innocent. You know, let's say I always like to go to, I don't know about y'all, but I like murder documentaries. I like watching them because I always try to figure it out before the documentary reveals it. It's like saying, you know, my client couldn't have done the murder because he was on a flight in the middle of the ocean, you know, like overseas. And I can prove it by bringing in his airline ticket. I can prove it by like asking the airlines to give us a copy of what's called the manifest, where they have a record of every person that's on the plane. My client's name would be on there. You know, that would be proof that my client couldn't have committed the crime because he was on the plane at the time of the crime. In geometry, we're not proving murders or anything. We are proving that something we say in math is true. So it's not as fun, I get it. Now what I want to say is, while you may not be good at proofs, I've taught geometry long enough that I've figured out how to show kids the patterns. You may not understand the proof part, but everyone's good at recognizing patterns, right? I'm going to show you the patterns so you can still be good at proofs even if you don't quite understand what you're doing. Does that make sense? So either you're going to get the proofs or you're going to understand the patterns. So you got two ways of being successful at this, okay? We're not really like, we're just going to dip our toe in the water with this one. So it's called third angle theorem. If two angles of one triangle two angles of one triangle, let's see if you know where this is going, are congruent to two angles of another triangle, what can you tell me about the third angle? Why? But why though? Like, what's their train of thought? If I didn't have it written up here, how would you know that angle C and angle Z have to be congruent? Same shape plays a role. What's the shape? It's a triangle, all right? I have two triangles. The other two angles are congruent, right? So it's like by default, the third one's congruent. What do we know about the angles of a triangle? We've practiced this before. The angles of a triangle, what do you know? Bam. They add to what? How many times? Like, how many triangles? All of them. Every single triangle has how many degrees in it total? 180, right? So if these two angles are congruent to these two angles, then by default, because the sum is 180 every time, then the third angle would have to be equal, right? So what you just walked through with me, by just casual conversation, is proof. You've just said into the courtroom, if I have two triangles and two angles are congruent, then the third angle must be congruent. Your proof was, I'm dealing with triangles. I know the sum of the angles is 180. You just said two of the angles are congruent. So then by process of elimination, that third angle would leave the same measurement in both triangles, which means they would have to be congruent. Does that make sense? So that's the way a proof works with this. All right, let's look at it and fill it in. So then angle C must be congruent to angle Z. Now what we're going to do is fill in the proof. This is called a two-column proof. You make a statement and then you give your reason behind it. Okay? It's not enough to walk in there and say, my client did not do it. You have to say, how do you, like, why? Why do you say that? How do you know? And that's where you say, well, because here's the manifest. He was on a flight. Right? So let's look at it. Proofs, y'all stay with me, we're almost done. Proofs always start here with a given. You got to have something to start on. You don't start with a blank page. You're always given something to start with. And then you always have a goal. The proof statement is your goal. We're starting with two angles congruent. The goal is to prove the third angle must be congruent. Now this two-column proof is 7 lines long. This is kind of lengthy. We will really stick around more 4 to 5 lines long. But this is a good proof to start with. Notice statement 1 is the exact same thing I started with. Do you see that? Always start with given. Take notes on here, okay? This is going to make it easier along the way. So you always start with given. I know that this angle is congruent to this angle, and that one's congruent to that. How do you know? Well, you gave it to me. It was given. Then what follows is a train of thought. Here's where people struggle. Here's where I'm going to start teaching you patterns, okay? So even if you cannot answer it because of a train of thought, hopefully you can answer it because you've picked up on the patterns. Next it says, so the measure of angle A must be equal to the measure of angle X, and the measure of angle B must be equal to the measure of angle Y. Here's where proofs are nitpicky. You just said they're congruent. Now you're telling me that they're equal. That's a pattern. It's definition of congruent angles. It means if I tell you two angles are congruent, then the measure of those angles are equal. It's a little repetitive. You would probably think to yourself, I don't need that line because you told me they're congruent. I know they're equal because they're congruent. Proofs are nitpicky. That's an example of where they're nitpicky. All right, look at the next line. It says the measure of angle A plus B plus C has to equal what? A plus B plus C has to equal 180. Here's a pattern. You looked at this, you look at the picture, you know it's a triangle, you think of what we've talked about. The measure of the angles of a triangle is always 180. Then you slide to the right and you answer, it says, blank line. How do you know this? Well, we've talked about it before. It was called the triangle sum theorem. I'm going to abbreviate theorem with THM. That's what stands for theorem. The word theorem just means a statement that can be easily proven. Okay? Don't get caught up in the words. All right, we've just said that the triangles add up to 180. Now look at the next line. Look at this mess. They've taken the entire A plus B plus C and said that it's equal to the entire X plus Y plus Z. How did they do that? What do you notice right here? 180, 180. They both equal 180. If they both equal 180, can you safely say, well, then they equal each other? Okay, so that is what's called substitution. What you've just done is said, this 180 is this expression, and this same 180 is this expression. So I'm just going to shove the two equal to each other by substitution. I'll take the 180 out, because they're both equal to 180. And I'm just going to put them equal to each other. Now, watch how they go from here to here. Let's look at it. X, Y, Z. Those all match. C matches. What do you notice here? What happened? A became what? And B became what? Look at your previous statement. How did they do that? So once again, they used a substitution trick. Notice here it says A is equal to X and B is equal to Y. So if I have A, I could actually write X. And if I have B, I could actually write Y. So this was a substitution trick. Now look at the next line. It's like a puzzle. It's like a giant puzzle. We had this really long statement, and then now all of a sudden all we have is C equals Z. How did they get from this long mess to here? What did they do? What disappeared? The X and Y's disappeared? Treat it like a regular equation, like if you were solving. If I have a positive angle X and I was to subtract angle X from here, and then I come over here and subtract it, because this was just plain angle X, does it disappear as well? What about with angle Y? If I subtract it from this side and then come over here to subtract it, because it's single angle Y, does it disappear as well? What am I left with? C and Z, which is exactly how they got right there. They used subtraction. They subtracted the same items on the left and the right. And then look at what we're at now. C is equal to Z. Well, if they're equal, then that means they must be congruent. Why? Because of the definition of congruent angles. So what you've just done is proven the logic of if I have two triangles with two angles equal, then by default the third angle is equal. and you've just proven it using a formal 2-column proof. Okay? Let's look at this together. So the assignment on Delta Math, I put the first few questions are reminding you of the sum of the angles of a triangle. So if you look up here, I gave you 4 questions just to get you back in the practice of knowing that a triangle adds to 180, no matter what type of triangle. So that's old stuff. Now here's the new stuff. The new stuff is, and you're going to have to read it because they're not giving you the picture. Remember we said all you need is the congruence statement. The question, the new part is, or not new part, sorry. The first question you have to answer is, can you even answer the question or not? That's what it means by can or cannot be determined. Meaning, I have enough info, yes, I can answer it, or I don't have enough info, no, I can't answer it, okay? So watch how I do this one. This is telling me I have 2 triangles congruent. It's giving me the letters. It says if CS is 23, find YT. Well, this is a side, right? Because it's 2 letters. It doesn't say angle. So come over here. CS would be the first and the last and the first letter. With me? CS. So CS is congruent to what in here? TF. Did they ask for TF? No, they asked for YT, which means I don't have enough info here. So the way I'd answer this question is I would say, okay, YT cannot be determined. Are you sure? Yeah, I'm positive. Because you didn't give me enough info. All you told me was the side that actually does not line up with YT. Alright, next. Let's get one that does. ZB. Alright, this one does. So, when you first read it, there's a lot of words. Don't let the words confuse you. It's the same thing we've been doing. You got a 4-sided figure. It's called FZVU. It says it can be mapped onto another 4-sided figure, PJWN, by translation. We just practiced translations. When we took a shape and we translated it, did the shape change size or shape? No, it just shifted, right? Slid right, left, up, or down. So what they're saying is that FZVU must be congruent to PJWN. Then it says if ZV is 17, ZV is 17, it says to find JW. Do those line up? Then what must JW measure? 17. So I would answer the question by saying, oh yeah, actually I can answer this one. And I'd go right there and I would type 17. Okay? Have, I think, 12 problems total, maybe? I don't remember. But as I've been standing here talking, I'm sure you could have breezed through the first 4 because it was the triangle sum concepts. So get that assignment done. That's your practice assignment.